Again, I do a lot of work in the notes with respect to Sturm's theorem, just for those students that are working through that to have some reference to what we're doing over here. So what I want to do is go to the whiteboard, go back to more basic things, and I think those basic things are probably the most important things you'll retain from math. So let's take a look. What's f of x now? We're in problem number 3, right? F of x equals x cubed minus 5x squared. And in this course, you learned a lot of things, certainly a lot of things that probably were more standard back in the early 1900s and then became less used. Sturm's theorem is still taught today, though. It's just taught at a more advanced level, all right? But anyway, let's write down the Descartes rule of signs: plus, minus, plus, plus. So let's see, we got one change here, we got one change here. So S equals 2, which means P could be 0 or P could be 2. The problem now is, like, you're gonna hunt for them now. And hunting for things can be difficult. I gotta be honest with you, I don't think it's gonna be that difficult. So let's take a look at it, and let's start writing things down. And I'm using the intermediate value theorem to do that. F of 0, really simple. That's a positive number. So let me, I made a mistake and put an equal sign over there. It's definitely greater than 0. Let's do f of 1. And I think it's going to be easy to do. I like to use integers because they're easy. F of 1 is going to be still positive. And then I'm going to do f of 2. A little more challenging for me, right? So f of 2, looking at it, 8, that's going to be definitely going to be negative, right? So now I know there's a root between 1 and 2. I know that. Now here's the deal. This is no longer a possibility. There's got to be 2. Now what does it mean? I know it's cubic polynomial. It looks sort of like this over here. So there's going to be another root. Let's keep going. Let's go to f of 3. And f of 3 is still going to be, let's take a 27, it's 45. I think I have to do that. 27, let's see, minus 45, plus 6, plus 6. Let's see, 12. Oh, it's still negative. All right, that's not bad. But at some point, it's got to poke through, right? Let's put f of 4 down. And what's f of 4 going to be? Well, 4 cubed, that's 1664, minus 5 times 16 is 80. And then I'm doing 4, right? Did I copy the right problem? And what do you get over there? Plus 8, plus 6. Wow, it's still negative. All right, at some point it's got to poke through. At some point that cubic is going to take off. Overpower everybody. What do you get there? 125, minus 125, plus 10, plus 6. This is definitely positive. So I found the other root. And what's that other root going to be? X has to now be between 4 and 5. And these are the nature of roots. Now, granted, there's one more. Now, I'm not going to use Descartes rule of sign to do that. The reason for that, there's one more. Right? It couldn't be complex, by the way. This is a real coefficient polynomial. If it was complex, they would occur in conjugate pair. So there has to be one negative root, by the way. So I'm going to look for it. So what's f of 0? Did I write that down? Oh, yeah, I did. F of 0 is greater than 0. Again, this is the function we're looking at. And let's do f of minus 1 now. That's going to be minus 1, minus 5, minus 2. Oh, this is clearly negative, right? Less than 0. So now I found the negative root. And that's between, well, it's between minus 1 and 0. All right? They want this. I gave it to them. All right? Now, granted, are there more things we could do? There are more things we could do. But right now, I think that's all they're asking us to do. Other than the fact that you probably should look at Sturm's theorem as well. Again, this stuff is all written in notes as well. I want to go to the picture. And this is problem number 3. They give me a picture. By the way, we got this over from Sturm's theorem. Figure 370. Got that root. I got that root. When I say that, I know their locations. We didn't get the roots, but I know their locations. Do I do other things here? Sure do. We're just going back to basic things. Okay, let me just remind you who I am. My name is Ron Bannon. If you need to reach out to me, my email address is Bannon. That's B as in boy, the @ symbol, NNON.US. All right, thank you.